In this video, what we will do is we will bend water. In order to do so, we will use a balloon and we will use a piece of wool cloth. We will charge the balloon by rubbing it with the wool cloth. This will cause the balloon to become charged by adding electrons to the surface of the balloon. Those electrons will then allow us to bend water. So let's go ahead and charge our balloon by rubbing it with the wool cloth. And we want to do that for about 30 to 60 seconds or so. And as you're doing that, you may start to hear the balloon crackling. Of course, you can try this also. That crackling noise, by the way, is just the electrons getting onto the balloon there and making the atoms on the balloon negative ions. Just rub it for a little bit longer. All right, okay. So now we'll start a stream of water. And you'll notice that the stream of water goes straight downward. However, when we bring the balloon in, you'll see that the water starts to bend towards the balloon. Okay, again, we'll let the stream of water roll straight down. And then we'll bring the balloon in. And again, you'll see the water start to bend towards the balloon. Okay, so question is, what is making that happen? In order to explain that, we're going to turn the camera off for a minute, and when we come back, we will explain what exactly is occurring. Okay, and we're back. Alright, so what exactly was occurring inside of the water or in that experiment such that it allowed it caused the water to bend towards the balloon? Okay. So as we indicated, the balloon, when we rubbed it, we added negative charges to the exterior of the balloon, okay? Those negative charges created an electric field, all right? With the water that was running vertically next to that balloon, that charged balloon, what happens is the water, you may not have known this before, water is actually a dipole, and it possesses polar permanent dipole moments, okay? And so because this is the case, what that means is, as you know, water is H2O, which means it has one oxygen and two hydrogen atoms in each of the molecules, okay? So these are our hydrogen molecules here, these two, and this is our oxygen, these are our hydrogen atoms, there we go, and this is our oxygen atom, okay? And so when these molecules here, these water molecules are brought within an electric field here, and this side being negative, what that causes is that it causes the positive charges within the molecule to move towards the negative charges here on the balloon, and the negative charges within the oxygen here to move away from the balloon. And so throughout the entire water stream, we have molecules that are rearranging themselves to look like this right here, causing this side of the water stream to be positive and this side of the water stream to be more negative. And because that occurs, as you know, opposites attract, and so the water then starts to bend towards the balloon because the opposite charges here attract each other. Okay, so this is what is occurring in the experiment, or what occurred in the experiment, as we brought that balloon that was charged negatively, which creates an electric field, close to a water, or close to a stream of water. And water again is a dipole, and it possesses dipole moments, and so which causes the water molecules to rearrange themselves so that the positive charges here move towards the negatively charged balloon and causes the water to bend towards the balloon. All right, so this is an explanation of what occurred.